Okay, this is standard reduction potential writing line notation. Writing line notations is basically a quicker way of writing what's happening in a redox reaction, the oxidation reduction, when you don't want to write the beakers. So when you have this situation right here, this is clearly showing that magnesium is getting oxidized, aluminum is getting reduced. So magnesium is losing 2 electrons at the anode, and the phases are separated by a line. The 2 lines separate the half cells, so the different beakers. And so then on the other side of these 2 lines, you're getting aluminum getting reduced. And so when you look at it, you're just, instead of writing this whole beaker thingamajig. Okay, and notice on this side, we have, on slide 39, would we be able to write a line notation with this setup? So give it a shot, and I'll do this right now. So here we have silver and copper. And so we want the cathode on this side, so we know that this is going to be Ag ions grabbing on to those electrons that are flowing this way. The Ag grabs on and becomes silver. So, and we know that because silver has a much higher potential than copper. So here we have copper solid dissolving into copper electrons or copper ions. The electrons then flow from left to right, from the anode to the cathode, and red cat gets fat. We're getting a buildup of silver onto this electrode. You need the salt bridge, just cotton soaked in some spectator ions, and because the electrons are flowing, we need to have offset it with a positive cation. And so the K pluses will go here. And as the Cu solid dissolves into Cu2 plus, we need to offset that positive charge with the negative spectator NO3 to offset the charges. And to write the line notation, you're going from left to right. So Cu2 plus, phase change into Cu solid, half cell difference, and we're going from Ag plus, phase change, to Ag solid. That's an Ag there. That's for silver. Okay, and that's how you do line notations. But then it gets a little bit an extra step if you have a substance that doesn't have any solid into it. So here you have copper 2 plus turning into copper 2 plus and copper plus, and then Au 3 plus and Au solid. So when you look at the redox potential, you're going to notice that gold is a lot higher in potential than the copper. So here's your gold, and has a reduction of 1.5 volts. And the copper, don't get confused with this copper, which is gaining 2 electrons to form a solid. This one is the one that you see in the example. It's copper 2 plus plus electron turns into copper ion. It's a much smaller voltage or much smaller reduction potential. So how do we know what's going to happen? Is we know that the gold is going to get reduced and the copper is going to get oxidized. Okay, so what's happening is now for the first time, they're going to put a cathode on this side, which is fine. So we know that this is where the reduction occurs. So we're going from Ag, and there's Ag3 plus, and electrons are going to flow this way because what's happening is you're getting copper plus getting oxidized, Leo, the loss of electrons is oxidized, and it's going from plus to 2 plus. So electrons are going this way. The gold, so that's an Au, the gold is grabbing onto those electrons and making the red cat gets fat. Reduction happens at the cathode. Okay, and the salt bridge, you're getting the electrons are flowing into this side of it. So you want your K plus and then NO3 minus on this side. Now notice that there's a phase change between, or there's a line notation between the reaction of copper ions. And so that's just saying that you need a surface, such as platinum or graphite, to act as like a conduit so that the electrons, after the copper gets oxidized, the electrons can grab on to the electrode and, on this side, the electrons can grab onto the electrode and start flowing from right to left. Okay, so what we're going to do is we have a platinum, then a phase change, a line notation, And then we have just whatever's in the beaker. Now they're showing from Cu2 plus to Cu plus. It doesn't matter how you write it. All you have to write is the fact that it's getting, that you know that this guy's getting oxidized because he's against gold, and gold had a higher reduction. So electrons are going to flow from right to left, and don't get deterred if they put the cathode on the left side. Just do everything we've been doing and just be a little bit more careful with how you're thinking about it. I think that's it. Okay, try the questions and we'll go on to the next topic, next video.